Welcome to the Universe Effect. I'm JP, and today we will tackle the age-old question, what is mass? Let's figure out how to calculate mass. So the weight or force of gravity is approximately rest mass times acceleration due to gravity, which is about 9.8 meters per second. Use the scale in your bathroom to measure the weight, and bada bing, you have the rest mass. So this is how we measure mass, but we still don't know what it is. I remember another equation that Einstein helped us with. Energy equals mass times the speed of light squared. This equation is a bit misleading because it only applies to objects that aren't moving at all. The energy mass equivalence equation for a moving object is this. Look familiar? Yes, Pythagoras is back to help us again, so let's make a right triangle. Okay, so if you don't know what momentum is, it's approximately mass times velocity. By adding velocity to our equation, we can find the energy of a moving object. This is further reinforced by the fact that if we make velocity go to 0 in our triangle, one of the sides disappears and you end up with two equal sides, E equals mc squared. The important thing here to remember is that mass is not converted to energy. It literally is energy. Okay, now let's look at an example. Say there's an object moving through space. If it's moving, it has some kinetic energy. And since energy and mass are directly proportional, when energy increases, so does mass. Yes, when something is moving, it has a bigger mass. Actually, most of the mass of an atom comes from the kinetic energy of the quarks making up its protons and neutrons. Let's talk about atom bombs. There's this interesting element called uranium-235. When a neutron is shot into its nucleus, it creates a reaction where the atom splits into two different atoms. Then 3 extra neutrons and a lot of energy is released. Why so much energy? It's because E equals mc squared. The speed of light squared is a huge number. It's about 8.99 times 10 to the 16th. So when the chain reaction starts, it causes a huge explosion. Nuclear reactors don't explode like an atom bomb because the reaction is controlled with the water inside the reactor. The heat of the reaction turns the water into steam, which pushes a turbine. We could go on all day about mass and energy, but the simple fact is we don't fundamentally understand what they are. Maybe someday one of you will figure out the biggest mystery of the universe. Share your thoughts and ideas in the comments below and we'll be happy to discuss them with you. If you like this video about mass and energy, don't forget to check out our other videos and the Universe Effect podcast. If you're the smartest person in the room, then you're in the wrong room.